So RapidMiner provides various extensions and inbuilt operators for statistical analysis of the data. So obviously there are a plethora of those here. If you are looking to find outliers, there's a whole set of operators around outliers that are available. But for now, I just need to find weight of my columns, which columns affect. So we're going to bring in, let's say, one of these several weighing techniques, and we're going to configure to see what the output looks like. So we'll run it one more time. But obviously this is 0 because everything was delayed, so I need to get rid of my filter, and we'll run it one more time. And what I see here is, like we saw, the departure hour followed by arrival hour, month, destination are important. In this technique, I'm doing it by one. I could obviously bring in another operator. Let's say I want to compare these two. I could keep building on this workflow and get the two results simultaneously. But what I have also done is I tend to combine few of these techniques and get an average, and I have saved that previously as a building block, again one of those reusable components. So I'm going to delete this, and I'm going to insert my favorite building block for identifying influence factors. This automatically creates a series of steps that combines weights and averages and normalizes them, but I can simply reuse it. We have the final output here, score between 1 and 0 normalize, and again similar to what we saw, but this is very clear indicator of what we saw visually as well as by some of the techniques. So I now know how these factors are important. Obviously, I may be able to do something like creating a dummy variable for each departure hour and each month and see if there are specific months that stand out. But before we do that, let's go ahead and save this workflow here first as determine influence factors. Like we said, now we need to do dummy coding of our data. RapidMiner provides various type conversion operators for numerical to binomial and various formats. So in this case, I'm going to first convert my numerical columns to polynomial, and I will select the subset of columns, and that will be my arrival hour, departure hour, and month, and apply. Please notice I'm selecting subset, but there are other various techniques to empower the user with various selection mechanisms. And once I have done the polynomial one, I need to now convert it to a binomial that will use a dummy coding. So we'll again select the same subset. That will be my departure hour, arrival hour, and the month, I believe, and hit apply. And we'll rerun the workflow one more time. As you notice in the output here, the factors that we saw earlier obviously seem important. 12th month, which is the holiday season, obviously seems to be terrible, followed by some early morning hours and some late evening hours. And then February, I guess it's because of the winter and so on. But as you notice, with several key additions, now we have a clear understanding of what's going on, what impacts our performance of flights. Obviously, we see that the weather plays an important role. So the next step we are going to do is get some weather data. We are going to rely on Weather Underground. This provides an API for getting airport data. I can pass in the airport code, the start date and end date parameters, and it provides me a lot of weather related data, which we'll see in a second here. But obviously there are hundreds of airports, so we need a way to variabilize this. So what I'm going to do here is start on a clean slate. We are going to get our 2007 flights data. RapidMiner provides advanced operators like looping on individual values of a particular column, unique column. So I'm going to use the loop value on destination. The value will be stored in loop value. And then inside of that, we are going to use RapidMiner's web mining extension to start pulling the data. The web mining extension is another rich set of functionality that lets you do crawl websites, get individual page or pages, do some HTML processing and so on. In this case, I'm going to use the get page API, and rather than passing in a hard-coded value, I'm going to pass in the variabilized URL, which is going to be replaced by the loop value every single time the loop runs. So we're going to provide that. The next part of this is when it downloads, I need to write this out file somewhere so that I can process it later on. So I'm going to write the document, and then we are going to provide the path here. Notice I have again used the loop value variable so that it creates a file with the airport code as a name. And just so that Weather Underground does not ban us, I'm going to add an artificial delay between each loop for a few seconds so that the whole process repeats after every 2 seconds. And then we can just simply run this workflow and see the outputs of these as they become available. Once the workflow completes for both 2007 and 2008, we should see a lot of files here. Each of these files, the name of the file is the airport code. And I can see there's a lot of weather related data. The first one is obviously the timestamp, and then things like the temperature, mean temperature, so on. So obviously we have now accumulated a lot of weather related data that we want to start using in our workflows. So we'll continue building a workflow in RapidMiner to read all of that data. Obviously there are a lot of files, but we need to combine this data. Once again, RapidMiner provides powerful operators like loop files where I can specify the directory to use, and then internally I can read those files. It automatically loops through every single file, and then at the end of the day I can append all of that data together and do some post processing like handling missing values, filtering out data set with some missing values, and then storing it in my repository here. So once I run this workflow, we should have the weather data available. The next part of this workflow is combining the data from the flight data and the weather data that we just acquired. So what I'm going to do here is get the 2007 flights data and then the 2007 weather data, and then we need to blend this in together. Again, RapidMiner provides a lot of operators for handling different types of joins. Various techniques like left right join are available as a simple option here. So I'm going to specify this will be my left join, and we will configure the ID column to use. So this will be based on my day of the month and day of the month here, and then followed on by the month itself and the airport code. In this case, I'm going to do the destination first, and that is what I need to do. We'll repeat this process for combining the origin weather data too, and then the workflow should look something like this. I have the flight data coming and then combining that with the destination data first and the origin weather. And you'll notice I'm passing this out as a result set itself, and that is saved as the central workflow. Now that we have built a workflow to combine the weather data, let's see what else needs to be done with it before we can use it. We are going to simply run the workflow here and obviously have various columns here. But one of the columns that you'll notice here is the events column, which has flags for rain, snow, and other weather events. So we are going to use one of my previously created steps, which basically creates new columns based on the appearance of certain words in the events column. So we're going to have a binary column whether there was a fog event or not, or hail event or not. And then we are going to do something we did earlier. We are going to use one of the weighing techniques to see how each of these matter. So I'm going to use weigh by information gain and sort it in decreasing order to see what the output looks like. So here we have the output of the weights, including the weather data, and obviously you see some influential columns like precipitation, temperature, wind speed, and so on. So at this point it looks like we have a good enough data set to start trying to build our models.